Actually, I thought maybe we can pivot. I'm just going to start throwing questions and left and right, mostly things that just happened on the chat. I have a
Go
couple
wild.
prepared, but let's just pick up with what Rich just said. If I don't know if he's still here, which is the Azure storage system doesn't believe in power management. So I don't know if you could explain that a little bit more. Oh, Rich isn't back, so I can't, I can't ask that question. Okay, let me ask it. Let me ask it. I'll come back to it and then ask a different question. So one of the things that Andrew Chen, he actually also on right now. One of the things he asked in one of his papers. There you
There we
are.
go.
You're right,
I
Rich.
got myself unmuted.
Oh, okay, super. Yeah. So if you could maybe explain why, well, not why,
Yes.
but why you believe
Um,
it, that
yes.
the storage system doesn't believe in power management.
A bit. My take on it is, and this is, and let me just say some background here. I mean, Ricardo's team has like been pushing power management everywhere in Azure, and I work on Cosmos, which has a combination of compute capacity and storage capacity, and so interacted with on this and compute capacity, very easy for us to adopt the power management, and it's sort of easy to, you can imagine how it's easy to shed load, for example, um, because there's lots of small tasks, and you can sort of move them around with great flexibility. But for the storage capacity, when I talk to my colleagues in Azure Storage, and our eventual goal is to be converting the storage capacity to Azure Storage. So I wanted to make sure that I was in sync basically with what they're doing for Azure Storage. Um, the concern on the Azure Storage side with the power management, I think, is about the sort of manageability of the storage clusters, and the SLAs that they want to maintain in the storage clusters, and sort of you know, I maybe just fear and unwilling to invest in it, but basically the fear that the clusters would be, harder to manage, and harder to, in particular, harder to be, meeting SLAs that they have.
Yeah, I mean that sounds. I think that actually is this example, and maybe the panel can. I'll throw it back to the panel in a second. This challenge that there are these expectations of how we've managed systems up to now, and which says, oh yeah, okay, your disk storage we've got to manage for 5.9 reliability or whatever else it might be, and anything that we do that's going to impact that is going to be a problem. Anything that we do on sort of energy management side usually goes in the other direction. It's like, oh, well, I'd like to be able to take these things offline, or I'd like to degrade the service, or I'd like to do something else. And that culture clash is going to be, I think, an issue, like I think going forward.
Yeah.
And
Yep.
I was like, the other pivot that I was going to have is sort of related to that, which is this paper that Andrew Chen had posted in the chat room, which basically showed that if you could reduce, this is a sort of a case study in Ireland where they have a lot of data centers, so that if you could reduce the power availability guarantee from 3 nines, which is the sort of current industry standard, to 2 nines, then you could like increase the total power usage, the available power, by about a quarter. So like a huge difference just by changing how many nines you might be willing to tolerate. Now, of course, to change it it's not, oh, like we don't want to turn on diesel generators to mask that. That probably won't work. But like if we could build, distributed systems like things, it says, oh, if we could be more power adaptive to even just, oh, your outages means that, oh, maybe you need to shift that particular workload somewhere else, or maybe we have some critical workloads that we're going to keep, and then other things that we maybe can shift somewhere else. It was that sort of an interesting observation. So
I think the storage cluster for the storage cluster would basically, it has customers making requests on us, on the storage cluster. We would need basically the cooperation of them. Like if we're gonna sort of say, okay, we're gonna like, change, give you some lower level of service, you basically have to go to them and say, you please shed your load, and therefore make that be acceptable for you. So it's sort of like an extra layer of involvement here in the load shedding.
yeah, I think that maybe I can kick it back to it. Esha, if you could maybe comment on how likely you think it is for cloud customers. I realize you all work for the same company here, but that this notion of sort of pushing the SLAs back or the power adaptivity back towards what cloud customers might be willing to do. I mean, they've definitely been pushing in the, hey, you should not violate my SLA up to 4 nines or whatever. If you can give me 5 nines, great, I'll take the 5 nines. If you can give me 6 nines, I'll give you the 6 nines. And yet, so if it's going to be the case that we're going to have more flexibility up the stack in order to be more energy efficient or even be able to provide the power at all, then is that a realistic outcome anyway? So I don't know if you could comment on it.
I do think that the AI boom is actually helping a lot with these conversations, just because we are in such a bad capacity crunch right now that the end customer will take whatever we give them. And so, when it comes to 3 nines availability, and we're not yet talking about 2 nines availability for services, right? We have gone down from 5 nines to 3 nines, and that is being received much better in all of the AI community as compared to what was true, up until 2 years ago. So that is definitely helping sort of increase deployments in this kind of like 3 9 capacity. So within Ricardo's group, we have done some work around multi-availability data centers. And those are a reality now and are being sort of pushed forward even more in the light of AI and power. So I do think that things are moving in the right direction. I agree with Rich that the conversation is much more difficult on the storage side, right? Like it's much easier to move certain functions or serverless things like inference over from one region to the other. But all of it still requires the storage to be in place. So yes, the storage story is always one step behind when it comes to these kind of solutions. But hopefully it'll get better soon.
I mean, what's
So
strange
can I
about
add
that?
a little
Yeah, sorry, go
context?
ahead. Go
Yeah,
ahead,
so
please.
this is an example of a broader issue, which is that when you have these technical problems, these constraints about power, people tend to assume that the way things are the way things need to be going forward. And so when you see these extrapolations of different things, almost always it's the world continues as it is. But we can redefine what service is, and being able to redefine what computing service is, what storage service is, in a way that it might be reliability, it might be something, it might be latency, it might be other things. But if you can evaluate those parameters, those relationships, those institutional decisions that people make, those incentives, you can revisit those and change them, then you have the potential to change the way the future unfolds. And I just want to flag it for everyone, because it's not just about storage, it's actually about all kinds of compute. And when we talk about computing services being delivered, we can decide what the best definition is for particular end uses. And the more we can segment them into different bins that have different needs, the better we'll be able to meet those demands at the lowest cost.
Yeah, Simon, I didn't know if you wanted to comment or.
I agree with the panel's response. I guess Rich, I'm happy you didn't say that the storage isn't a power problem. Perhaps maybe actually the question back to you would be what you see. I don't know how deeply you're involved with the storage group there, but what you see.
I'm in the
trends,
storage group.
Okay.
I work in Azure storage.
Okay, good.
Although I tend to work, most of my my effort is really on this, on not the main Azure storage product, but on this, Cosmos big data analytics
Right.
service, which we have storage in it, and but as I alluded to earlier, like the big project, I would say du jour, but actually it'd be of like multi-year project. A big multi-year project is for me is like taking basically converting from using this, Cosmos storage service to just using Azure storage directly.
Yeah.
So that, anyway, background for all you guys.
I guess my question was, in terms of power trends for storage, do you agree that the kind of direction is not down, potentially up?
Yeah, absolutely. Yeah.
Okay.
Anish, did you want to generalize a little bit here? I don't know if you thought your question was answered already here.
I think it was somewhat answered, but I can just rephrase it to the panel. Because I feel like in general we've had talks about like SLAs, and in that sense, how do you feel about in the sense where do you think if the SLAs change, you would be more fungible to new mechanisms, or do you need to see the new mechanisms in order to determine new power aware SLAs? So I'm curious like what your take is there.
So for sure, like I think we have enough in the toolbox already, such that if there was SLA slack, I think somebody called it in one of the talks, if there is an official SLA slack from the user, we can use it, right? We can use it to schedule it in the right setting, such that it's only a very small differential power more than rather than sort of starting up a new machine for it, or starting up bringing a machine back from idle just to run it right now, right? So there are already a whole lot of things that can be done. There's a green slider, if you will, that we have at our disposal if those SLAs were available, those SLA slacks were available to us from the user. So yes, I think having that kind of an interface will definitely allow us to do much more even today.
Yeah, I can perhaps add to that. Cloud users are notoriously bad at specifying their need predictions and tend to over predict, so not to run into problems. So perhaps in addition to the slider, if we had additional tools that could help us identify what the real slack of an application truly is, as opposed to the slider that the user of the cloud was setting, that could help kind of bring that further. That also I think goes a bit into the mechanisms, Anish, that you brought up. Even in the absence of accurate prediction, having more nimble mechanisms would actually allow kind of systems level software to quickly context switch between applications. So I think a limiting factor often is the overhead involved in the existing mechanisms to be able to switch back and forth, critical load, non-critical load. If that becomes more nimble, if we could easily vacate a server, bring loads back to a server with much lower overhead, then we could essentially afford to be less accurate with what we need to predict in terms of what service we need from a particular server, and just swap in and out much more efficiently than today. So I think on those two axes, we could push further. Prediction of what the real SLA, or deeper insight of what the real SLA of workloads are, but also making these operating systems and other systems mechanisms more nimble, so that we can afford to actually move loads much easier, and we wouldn't have to do as much prediction.
I'd like to build on that a little bit. SLAs are kind of backward looking. They're kind of built from the past experience. And so I think it behooves everyone who delivers computing services to revisit those periodically, to have a process where you kind of look at them systematically based on the needs of your customers, and then engage in that dialogue with the customers to figure out how it could be changed to make your life easier and make their life better. And I think that if you're not doing that kind of reevaluation, you're going to be stuck with a lot of legacy decisions that people have made historically that don't necessarily apply going forward. And it's important to have processes for reevaluating, because these kind of changes in institutional arrangements are a key way for us to improve performance and efficiency going forward.
Yeah, I mean, it is one of those strange things from this. Taking the storage example as one, like everybody who's storing data is actually replicating or really cares about their data. It's replicating across data centers. So the notion that I can't turn off, I need the reliability of this particular disk to be X, or this particular, disaggregated storage service to be X is weird, right? It's like,
Yeah.
from the customer's perspective, you're like, oh, you didn't really need that.
Right.
So, but let me pivot and ask the panel actually a more general question. I stole this idea for asking this question from one of my favorite interviewers, which is, were there topics that you thought we didn't cover? And or what would you think of the most important thing that we didn't discuss today, or that we didn't discuss enough today? And maybe I'll put Esha on the spot for that one.
Didn't discuss today. I don't know. I think Partha's talked about everything that we should be doing. But I think we should probably look a little more into the disaggregation part specifically, right? A lot of the underutilization in the data center just comes from not a good fit, right? And the problem gets worse and worse when you start seeing a large chunk of the workload in the cloud being exactly the same, right? Which is a direction that we are moving into very quickly. And if the workload is looking very similar, and yet we don't really have a great fit for it, especially because today we have all of these different kinds of accelerators, but the high bandwidth memory is not something that we can plug in and plug out of any of these accelerators. And so when we talk about right fit, it's often difficult to find that. So yeah, I think disaggregation in that sense today would really help with cloud efficiency in general.
Yeah, I mean, it does seem like, just to comment a little bit on that. I mean, I think it is clear that sort of AI workloads are not going to have the same sort of behavior patterns, potentially anyway, sort of demand patterns that existing ones have sort of become really familiar with. I mean, it might well, like for inferencing, maybe actually is going to be similar, or possibly it says, okay, maybe what you can do is damp down the quality of the, that's another kind of question on the ML side. If you damp down the quality of the inferencing, would that allow you to save energy on a particular point, and still providing the service that you're interested in, but possibly do it just a little bit less well? I don't know, Simon, if you had a thought as to.
Oh, definitely.
I know one way of asking the question as well would be, oh, what do you think there's part of this is to try to generate a set of think of research tasks for the community to work on, and so another one would be, okay, which thing do you think the research community isn't working on enough, right?
Yeah, I agree with Esha actually that disaggregation, I think, is a big topic when it comes to shifting load in particular. I think it can help there quite a lot, and so that is interesting to consider more. I would have also liked to hear more discuss more about this idea of prime power that Yue brought up, that data center operators increasingly have to work together with the utilities, not only in kind of addressing the load variability on the grid, but also actually in helping provisioning the power to the grid, and what that may look like, and what role we as systems researchers may be able to help play there as well. And then finally, AI, I guess, as a solution to the problem. Partha talked about it a little bit. There's this kind of vignette he had about the kind of 10 to 15% improvement due to using AI techniques. I wonder, there surely got to be more on that side as well, and I would have been curious to see more on that.
So I have a couple of things to add.
Sure.
So one of the things that I alluded to in my talk that I think is under analyzed and doesn't get nearly enough focus is this question of the other ways we can improve efficiency and performance. I think there's a whole bunch of people focusing on different aspects of it, but I think it's important to start creating that narrative. And some folks in the industry are doing that now, but you still see these stories about, Moore's law is ending, it's a huge crisis. Well, some things are slowing down, but other things we're getting better at. There are things that we need to get better at that require different kinds of innovation, that require institutional change, that require changes in incentives. And those kinds of things tend to get underreported and are not as much of a focus because the tech industry loves tech. But really, a lot of these problems are institutional problems. They're people problems, and they need to be understood in that context. And in order to capture what efficiency and performance improvements we can get, we're going to need to change the way we've been doing things. We've been relying heavily on the Moore's law progression, the die shrink, and so on. But we're going to have to change what we're doing. So that's one whole area. Then there's another thing that I started thinking about as the conversation was going on about storage. One of the problems that the providers have is that their customers haven't really yet organized themselves around using IT for delivering business services. When I did some work for eBay about 10 years ago, Dean Nelson there hired me and a group of Stanford students to focus on their transition to a more organized way of using IT. But the idea from that was you need to go through a process. These customers need to go through a process of mapping their business processes onto IT infrastructure so they could actually answer the question, I spent this much on IT, this is the business result. And very few companies have actually gone through that process. And I think it creates frustration for the providers because as some people already said, I think Esha mentioned it, they don't know what they want. They don't really have a clear sense for what they want and what they're willing to pay for. And so this isn't so much a problem of, again, it's not a technology problem, but it is a problem that affects the provision of technology because these companies haven't gone through this process to, reorganize themselves and be able to answer the questions about if I spend this much money on technology for this business process, this is my ROI. So that's a kind of general problem that I think as an industry we need to think about and face because there are definitely companies that have done it. eBay under Dean Nelson did it. It was a huge, big pain, but they figured it out. But it's hard and it takes a lot of work. And I think it's just something for the providers to think about because their customers can continue to be very frustrating because they haven't solved their own internal problems. So anyway, that's my 2 cents on that.
One could think of that as a market opportunity, but yes, go ahead.
Yeah.
Sorry, I just wanted to build on that as Johnson was speaking about like the customer. One of the biggest challenges when doing energy efficiency or power efficiency work is how do you convert that into an incentive or reward for the customer, right? Because there are a lot of things that we could do that don't necessarily bring the TCO down for us as cloud service providers, or they don't bring it down enough to sort of become a good enough incentive for the customer, for the end customer to want something like that. And this is especially true when we're talking about something that brings down performance in lieu of reducing energy or power. And I think that we need to have some, of course, there are people working on policy and strategy and like trying to define these things. But even within the community, I think we need to, there is something called GSF, I think Green, I'm forgetting the full form of the acronym, but we need something that kind of defines these incentives globally that we can use across CSPs. Because today, honestly, like we have certain solutions, even in the AI space, right? Like where you can count your carbon credits, count your carbon emissions that were used for a certain training or instance. And the only customers that are using that are like maybe airlines industry or oil industry, right? Like people that really care about their perception, their public perception in terms of their carbon emissions. And in order to grow the customer base that asks for these kinds of initiatives, we really need to figure out what the incentive needs to be for the end customer.
Yeah, I mean, I thought, yeah, sorry, go ahead.
It almost sounds like the incentive is going to create itself as we sort of progress further into climate change. Governments are increasingly starting to introduce carbon taxes and other incentives that then ultimately I think will trickle down to those customers to start to want these things. And it seems like you said, Esha, that's starting from a kind of reputational perspective. You're right. Airlines and oil companies, I would also expect to be the first ones because they have the worst reputation right now. And I feel like this is going to, the perception in society is changing more and more. And I think eventually that incentive may just create itself.
Yeah, I mean, I think I'd also echo this point that Ash had made earlier of, well, potentially also the difficulty of actually acquiring any sort of AI resources for an enterprise right now sort of drives potentially a different model of how things are. And I think like over the scarcity
right?
is really like drives change. So I mean, I think one of the things that we can do as researchers is sort of predict how the world has to look in the future, even if it seems very hard to figure out how we're going to get there, and then try to build an environment that looks like that, because like industry will catch up and say, oh, actually we needed all of that. So so this notion of like being able to build in systems where you can have customers, it seems very much like, oh, the world we're going to have is if the power companies are going to be providing power in a sort of staged manner, like, oh, different levels of power at different levels of reliability, and that's then visible to the cloud providers, and potentially that ends up needing to be visible back to customers, and they just need to program against it. So we need to come up with techniques to make it plausible for people to do that. Let me pick up, I think I was gonna Anirudh had a question if you wanted to go ask it. It was about edge services, so I could do it for you, but if you could go yourself, that would be okay.
Yeah, I mean, I don't actually have too much knowledge in this energy space, or honestly the data center space either. But like I know Jonathan was mentioning earlier in his talk that like we have to kind of think about how we can have solutions outside of data centers themselves. And I think like one example you were giving was the edge computing like kind of landscape. And I was wondering like could the growth of edge computing actually like could that lead to both better SLAs as we were talking about earlier and could lead to, more favorable power consumption and meeting these requirements as well?
As always, it depends. So the numbers that I quoted in the talk, like roughly 1% of the world's electricity is data centers. 1%, a little more, is for the networks, and that would probably include what we're now calling edge computing. It's going to evolve over time, and then you have all the end user devices. I think that and that's another 2%. So typically the numbers that are well accepted now are kind of 4-ish% for all ICT, right? So the edge computing, I think, can help in certain situations. I mean, we have the CDNs that are used by many companies to distribute content, turn out to be a pretty efficient way to do that, because and it's kind of like a distributed, maybe it's not quite edge, but it's edgier. But I think that there's a kind of tendency to push things out from the core. And some of that will be more efficient, but there are real economies of scale for certain kinds of compute. And I think you're going to end up with more and more of this kind of segmentation. For certain kinds of workloads, edge compute is great. And actually, your phone is an example of something where they pushed certain things out to happen on the phone that used to happen in the data center, right? And so you're going to see a lot more of this stuff, but it's going to be greater and greater disaggregation and segmentation of different loads. And so I don't know that anyone can really predict whether that's going to increase or decrease electricity use, but it'll certainly, I assume, deliver computing services in a way that's better for the customer, because that's been the history over time.
Yeah, maybe to build on that a little bit, edge computing has the potential to spread out power use. We've seen the example here that the kind of centralized data centers have this problem that they're all in one place and they're straining the utility in that place. So moving towards the edge has that benefit. There may be even a middle ground. I believe Andrew Chien actually has worked on kind of analyzing what if we were to build smaller data centers that are kind of more distributed. In that case, could we use this for this sort of spreading, but also to, I think, use more renewable energies as the sun moves around the globe? We can kind of build data centers in very strategic locations there to capture that better than we currently do. I think John already said this. The trade-off that one runs up against is that there's a kind of net energy efficiency benefit from consolidation and bringing things closer together. And in a sense, it's kind of Moore's law at a much, much larger scale. You run up against that kind of problem. You have that trade-off. Is it going to be better if I just centralize everything, even if that means that I now have to procure all the power to that central place, but I do get the economies of scale effectively of having everything in that shared location? Or do I get the benefit of being able to spread things out further? And I think the answer is probably you want a little bit of both. Yeah, we're going to see what's going to happen with edge computing going forward.
There's one more nuance to what you just said, which is that the centralized facilities have an easier time procuring renewables. It's because they have teams of people all organized, they're big enough scale to be able to do that. As you spread more and more computing to the edge, it kind of distributes the responsibility and makes it harder for those big players to purchase renewable energy. Right, because different smaller players are responsible. They don't have the same teams of people to do that sort of thing. So it kind of it's definitely going to be a mixture, but it kind of cuts in a couple of different directions. It's hard to predict where it's going to go.
Indeed, and at the same time, it provides that additional necessary real estate for the rather large footprint of, say, solar panels and wind farms.
Yeah, and just to build on that. The one thing that we lose a lot when we go towards these smaller edge data centers is availability, right? Like the kind of availability that you could get from these central cloud data centers is not something you would get from the neighborhood small data centers. And in a way, given that the workloads would be smaller because of the fragmentation issues, the availability would be less. In a way, if we are able to move towards that format, we are probably going to sort of force filtering out the SLAs, the high SLAs that are not needed, right? Like if it's cheaper for the customer to run in a local edge data center, they might sort of go for those smaller SLAs, less strict SLAs, and take that up. So I think it might kind of cancel out in terms of what we lose and what we gain, sort of thing.
Yeah, I mean, I do think that the cloud customers, I mean, I think like one of those trends that I think is happening, Martin Casado had a nice article about how much money people are how much money like companies are spending on the cloud, sort of implies that sort of the optimization side of, from their perspective, they're spending all this money that they could actually improve their profitability, stoke up their stock price or whatever, provides them potentially an effective approach to it if that allows them to do, things are cheaper because it's actually easier for the cloud vendors to provide, then that becomes a plausible story for how those incentives are. Let me then pivot to the sort of forward-looking question. Like researchers tend to ask the question like, oh, what's life going to look like 10 years from now? And so pick 2035. Actually, it was really great. We had the picture of what the Phoenix area power grid was going to have. I thought was super interesting about that graph that we saw was, okay, total power generation in Phoenix was going to be 2.5 times greater. The amount of carbon produced by that power grid was going to be exactly the same. That all of it was going to be demand increase, like all of the improvement. I mean, Esha, you sort of pointed this out too, which is, oh, okay, we're scaling up green energy as fast as we can, but then we're using it all as fast as we can too. So we're not actually taking things offline the same way that we would otherwise. So maybe one of the questions would be like, I actually think that you're going to argue with each other about this, which is, what do we think the total fraction of energy used by data centers, and we'll include edge too, I guess.
Can I add
Yeah.
some context first before we
Sure.
start fighting?
Yeah.
So the first thing to understand is that data centers aren't everything. We know that. And we're in the mode now, for climate reasons, of a move towards electrification of everything. And so if you electrify all light vehicles in the US, that's about a 20% increase in total electricity use. If you electrify heating and a bunch of other industrial process uses and everything else, that's where the big numbers are. And that's where you end up with full electrification is like 2 to 3 times increase over what we have now in terms of total demand. And that would happen over decades, but it's not just that the electricity used for data centers might be increasing. It's that there's a bunch of other stuff going on as well. So that 2.5 times in Arizona, I think, is anticipating a bunch more electric vehicles, a bunch of electric heating and more cooling and other things. So that's part of the context. Another part of the context is it's really kind of crazy to estimate ICT electricity use more than a few years ahead. And there are people, you laugh, but
no, it's fine. It's fine. Push back on the question I'm asking. Yeah,
okay.
That's fine.
Okay. So the people make these wild extrapolations, and there are some people whose names I won't mention who keep doing it, even though history has to this point not really justified it. There's been a period of a doubling of electricity use for data centers from 2000 to 2005. Been pretty flat since then. AI promises perhaps to push that up a bit. But we're starting from, for data centers, a 1% base, for networks, a 1%. So let's start from that baseline. Here we are at 2% for data centers plus core network plus access networks. And then let's talk about, going forward. I would caution everyone not to think about 2035 because who the heck knows. But I'll make a guess if as long as it's kind of Chatham House rules and no one's going to repeat it.
Well, it's all on tape, so But
okay. No,
I mean,
okay.
it sounds
Well,
well, one could make an argument. I'll take both sides of this argument, just so again, in terms of context. So one view of the world is, okay, we're going to be limited because of the need to electrify and green transportation and home heating. I think by 2035 we're probably not going to be that far along towards electrifying heavy manufacturing, but at least we'll have made some progress towards electric vehicles and towards electric home HVAC. That's gonna that the need to do that's going to mean we're going to have to be growing the power grid by this enormous amount. It's going to put a lot of strain on things. The ability for data centers or for IT to add to that is going to be, there's going to be a lot of pushback against that, just because people don't want their power. This is what's happened in Ireland. Like, don't want their power grid to go wonky just because a bunch of people want to surf the web. And they may not see the benefits for it from a sort of public perspective. And so as a consequence, we're going to just live within a power budget. Like, there's going to be a power budget for IT. We won't be able to expand it that much, and therefore we're just going to have to figure out how to do the optimization. So all of it, you could look at this question not on what the demand would be if we had infinite capacity, but rather just what the demand will actually be, what the supply will be, and that will be what will constrain it. And we'll just need to make everything else work around that. And that would be one view of the world. That would be one view of the world. I suspect that possibly the technologists on the left side of my screen here might say something different. So, okay, why don't you go ahead, Simon? I could take you,
Okay.
and then we'll give Esha the last word.
I'm not actually going to disagree, because I think I would say maybe two things. First, the demand for compute has never gone down. So I think maybe this is kind of the turbocharging John's argument about don't make too far predictions, because you're probably going to be wrong on the downside. You're going to be too low, and they predict the power consumption of that compute demand by the next killer app that is going to be out there is going to be so much greater than anything you had ever predicted. Now, as a fraction of the grid, like John says, because we're kind of electrifying everything else, it's kind of hard to say. But I feel like that fractional question is actually a bit of a red herring, because the effects of the grid being so strained by all these workloads coming onto the grid means that data centers are going to be affected just the same. We're already a large enough power customer that we have to kind of play with the grid and help the grid stabilize it and procure the power. And I think that is just going to continue no matter whether we take up a bigger fraction of the total global power grid or not.
Esha, do you want to? We're at the end of time, so you could also I don't want to say anyway, but we're interested in your answer. And
now you have to provide the opposing view, Esha.
So I think I agree with all of you, right? It's very difficult to obviously come up with a number, especially when we don't know what the overall increase is going to look like. But the trend is definitely upward. The trend is increasing year on year, right? Even if you look at the data center capacity as it was growing up until 2022, that was also year over year increasing. That the percentage added would be higher every year. And so, with AI, we can guess that it's probably going to be turbocharged. But I don't know. I think we all need to work with UA and the utilities as much as we can.
Yeah, I mean, I think that there's an argument. I'll state the counter argument. I mean, I think that the story that I would say is that the IT industry is this massively successful business built around converting electricity into cash. And the consequence of having a mechanism to turn electricity into cash is, well, then you have a huge incentive to go build a bunch of power plants and to solve a set of problems on the generation of energy. So this notion that it's going to be limited in some way is not so clear. And what's also, I think, true, and maybe a caution about over relying on our history, is that it is the case that there was server consolidation and move to hyperscalers really meant that any prediction about this in the past has been overblown. It's still the case that all of those optimizations that have sort of meant that we've kept in a reasonable way up to now, those don't apply in the future. The things that we did to solve our problems in the past don't actually help us, because the server consolidation has already happened. The move to hyperscalers has already happened. So what? What?
Can I answer the now what question?
Yeah.
How many of you believe that software is optimized? How many of you believe that software bloat has gone down? Okay, so that's one whole area where it's a wide open field. We haven't optimized it for it at all. Companies have traditionally tried to minimize programmer time. And part of the reason for that is that they haven't been rewarding the programmers for reductions in total costs or increases in profits. So all that stuff can be changed. There's a whole, recently, I was at a Gartner event where I got to talk to 6 CIOs of big companies. It was super fun. One of the things that I learned in that, as I was talking about these different ways to improve efficiency, one guy raised his hand and said, I just learned about this new algorithm for optimizing sorting. Right? Sorting is a really basic thing. But recently, in the last year or two, there's been amazing progress on that. And the big companies like Microsoft and Amazon and Google have an inherent advantage there because they can apply such an algorithm across their whole software stack fast, right? So again, algorithmic innovation, huge thing. There's always more things you can do. It's very specific to workloads, but there's always more things you can do. There's all this stuff on segmenting workloads and hardware, software, co-design. So I would just caution against assuming that a growth in service demand will necessarily result in a growth in electricity use, because there's going to be massive incentives for the industry to capture these other ways of improving efficiency and performance. And so I just don't, well, I don't know what the number will be. And I think if I had to place money on it, I would say electricity use for data centers and networks will probably go up in coming years. I just don't, the wild extrapolations of it's going to be 20% of the world's electricity in 5 to 10 years, it's crazy. It's not happening because there's so many ways we can improve efficiency, and the incentives will be, as you said, if there are constraints on power production, guess what? That means the cost of doing these other things will be weighed against the cost of the Microsoft buying or paying for new power infrastructure. And almost certainly these innovations are going to be cheaper than putting in new power infrastructure. That I would put money on.
Yeah.
So anyway, so I think there's so much provision for efficiency improvement that it's, we're not going to get this, 20% of electricity demand being data centers. It's just not happening.
Yeah, so since my own research is primarily in the direction of trying to make computer systems more efficient, that I really like that story. Like that seems like a really great. This is like reinvent the idea that we should do. You might think that I'm actually arguing it's going to be terrible. No, it's.
Oh, I'm not. Yeah, no, I don't think you are.
We need to figure out how to. I mean, what the university business is, like what university research is, or what research in general is about, is trying to anticipate things that before people need them, and then coming up with solutions for them before they need them. And that today people don't necessarily realize, okay, 5 years from now, you're going to need a set of tools to be able to optimize the software stack, because that'll become important. And that notion of like what will become important in the future is actually something that's super important for us to be able to understand and anticipate, because that's where like a bunch of research success comes from. Okay, thanks very much, everybody. I'm going to call it a wrap, and I appreciate very much the panelists of it. Thank them again. Let me clap. Like I was gonna, we go put our clap icons on,
and clap for everybody else.
Yeah, we can clap here. Anyway, thanks very much for also all the speakers. That's been super helpful. I appreciate all of your time this morning. So
indeed, thank you very much.
Everyone. Have a great rest of the day. For those
Thanks
of you.
Thanks a lot for organizing.
See
you later.
Thank you.
Bye-bye.
Thank you.
Bye.